Hello students, today we start with the third part of chapter Kinetics of Particles, in which we'll cover impact, impulse and momentum. This chapter of impact will be covered in two parts. So this is the first part of the impact topic. So let's start first with the definition of impact. Impact is collision of two bodies which occurs for very small interval of time and during which the two bodies exert a very large force on each other. Now we have to understand the terms related to impact. So two important terms are there. One is common tangent and another is line of impact. Now, if you look at this diagram on the right side, now two bodies A and B are colliding. All right. This is a common tangent. All right. Or common surface of contact between two bodies. This we call it as common tangent. A line drawn perpendicular to common tangent at the point of contact is called as line of impact. So what is line of impact? A common line drawn normal to the surface, common surface of contact between two bodies at the point of contact. As in this diagram, this is common tangent, line drawn perpendicular to common tangent at the point of contact is called as line of impact. So this horizontal line is called as line of impact. Now, classification of impact. The impact can be of two types. One is central or non-central. Another can be direct and indirect. Now, central and non-central. If the CG of the two bodies during impact are lying on the line of impact, that is called as central impact. Like in this diagram, you can see the CG of the two bodies A and B, C1 and C2 are lying on line of impact. So it is called as central impact. Whereas in the upper diagram, CG of the two bodies C1 and C2 are not lying on line of impact. So what it is called as non-central impact. Next, we come to direct and indirect impact or direct and oblique impact. If the velocity of the two bodies before the collision, before the impact are just collinear with the line of impact, we call it as direct impact. If the velocity of the two bodies before the impact are not coinciding or not collinear with line of impact, we call it as oblique impact. Now look at this. This diagram, initial velocities of the two bodies just before impact, UA and UB are coinciding or are collinear with line of impact. So this is called as direct impact. Now, in this diagram, velocities of the two bodies just before impact, U and UB, are not coinciding or not collinear with line of impact. It's called oblique impact. Even in this diagram, also, U and UB are not collinear with line of impact. This is also example of oblique impact. To put together, this diagram is example of oblique non-central impact. Oblique impact because velocities U and UB are not collinear with line of impact. CG of the two bodies C1 and C2 are not lying on line of impact. So CGs are not lying on line of impact, non-central. Velocities are not collinear with the line of impact. This is oblique. So put together, it is oblique non-central impact. This diagram is example of oblique central impact. Why central impact? Because CG of the two bodies are lying on line of impact. Initial velocities U and UV are not coinciding with line of impact, so oblique. So put together, what we call it as oblique central impact. Third diagram is example of direct central impact. CG of the two bodies C1 and C2 are lying on line of impact. We call it as central impact. Initial velocities are collinear with line of impact. We call it as direct. So put together, this diagram is example of direct central impact. Students, as per our syllabus, we'll learn direct central impact. Then we'll come to oblique central impact, and then we'll have certain problems which will be combining the concepts of dynamics with impact, like impact plus work energy or impact plus projectile. These are the two important combinations of the concepts what we come across in the chapter. So first we start with the direct central. Okay. Here let's understand the concept of direct central impact. Look at the diagram. Here you can see that there are two bodies having masses m1 and m2, having their velocities u1 and u2 just before impact. v1 and v2 are the velocities of the same two bodies just after impact. Impact will happen only when the velocity u1 is greater than v2. During this impact, it is assumed that there is no external force involved. So principle of conservation of momentum can be applied. That means momentum before impact is equal to momentum after impact. What will be momentum before impact? m1 u1 plus m2 u2. What will be momentum after impact? m1 v1 plus m2 v2. This v2. So this way, this is principle of conservation of momentum. Momentum before impact is equal to momentum after impact. That's what is one formula what we use for solving the problems of direct central impact. Next is coefficient of restitution. Coefficient of restitution is denoted by E. It denotes the loss of energy during impact. Its value is determined experimentally. This will be one of the experiments what we will be doing it in the mechanics laboratory. It is defined as the ratio of velocity of separation to velocity of approach. Look at right side. Here E is equal to velocity of separation is in the numerator and velocity of approach is in the denominator. Velocity of separation will be V1 minus V2. Negative sign, since negative sign has to be put outside. If you remove the negative sign and simplify it, so final formula what we will be using it for solving the problem is E is equal to V2 minus V1 upon U1 minus V2. So there is no need to use the negative sign. Now we have to understand the limiting values of E. Limit value of E ranges between 0 and 1. Minimum value of E is 0 and maximum is 1. Now understand the two extreme cases of E value. In case of perfectly elastic impact, E is 1. If E is 1, that means there is no change in velocity before and after impact. That means kinetic energy of the system is conserved. There is no loss of kinetic energy. Loss of kinetic energy, that means kinetic energy before impact and kinetic energy after impact are same. Second, in case of perfectly plastic impact, E is 0. If E is 0, you substitute E is 0 into that. So that means V2 minus V1 is 0. That means the V2 is equal to V1. That means two bodies are merged together. If the impact is perfectly plastic, two bodies are merged together after impact and they move together with a common velocity. Now, suppose somebody asks you to calculate the loss of kinetic energy. Loss of kinetic energy is what? Kinetic energy before impact minus kinetic energy after impact. So what will be total kinetic energy before impact? Look at this side, half m1 u1 square plus half m2 u2 square. This is total kinetic energy before impact. What is total kinetic energy after impact? Half m1 v1 square plus half m2 v2 square. So I think this is all the basic concepts of direct central impact, which probably we know it from previous level, but I have covered all the basic concepts. Now we are ready to start with the problems on direct central impact. Okay. Problems on direct central impact. I'm reading question number 1. Two spheres A and B are traveling along the same straight path in opposite direction. Sphere A is of mass 1.2 kg is moving with 5 meter per second towards right, and sphere B of mass 2.4 kg is moving with 2.5 meter per second towards left. If the coefficient of restitution is 0.8, determine their final velocity. Students, E is 0.8. Need to draw a small diagram. This is sphere A having mass 1.2 kg. This is B having mass of 2.4 kg. This is moving to the right with 5 meter per second. This is moving to the left with 2.5 meter per second. For solving any problem of impact, you need to adopt sign convention for velocity. I have written it here a note also at that. Before solving any problem impact, sign convention for velocity should be adopted. Now here we have adopted the sign convention. We are taking towards right as possible. UA is plus 5 meter per second since towards right. UB is minus 2.5 meter per second since to the left. Applying law of conservation of momentum or principle of conservation of momentum. Momentum before impact MAUA plus MBUB is equal to MAVA plus MB. Now you will substitute the value. MA is 1.2, UA is plus 5 plus MB is 2.4 into UB is minus 2.5 is equal to 1.2 VA plus 2.4 VB. Left hand side becomes 0. So you get one equation 1.2 VA plus 2.4 VB is 0. Now we will apply coefficient of restitution formula. Coefficient of restitution is what? E is equal to VB minus VA upon UA minus. Given value of E is 0.8 is equal to VB minus VA upon UA is plus 5 and UB is minus 2.5. So if you solve it, VB minus VA comes out to be 6. Now you have got two simultaneous equations in terms of VA and VB. We'll solve these two equations. You get VA is minus 4. Minus 4 means it is not to the right, it is to the left as per the sign convention. Sign convention we adopted towards right as positive. So we got a VA value as minus 4. That means it is to the left. Value of VB comes out to plus 2, that is 2 meter per second towards right. So this is your final velocities just after impact. These were the velocities before impact. These are the velocities just after impact. All right. Next problem. Problem number 2. Two balls with masses 20 kg and 30 kg are moving towards each other with the velocities 10 meter per second and 5 meter per second respectively. It's more or less identical to what we have come across in the last problem. If after impact the ball having mass of 30 kg reverses its direction and reverses its direction of motion and moves with velocity of 6 meter per second. Then determine the coefficient of restriction between the students. This slight some misprinting has happened. This is again, you can assume that there is a sphere of is A. Here this is a ball of B. Mass of ball A is 220 kg. Mass of ball B is 30 kg. This circle has been misprinted while making PPT. All right, I hope you understand. So ball A is moving to the right with 10 meter per second. Ball B is moving to the left with 5 meter per second. Mass of ball A is 20 kg. Mass of ball B is 30 kg, as in the previous diagram on this side also. Just circles are missing in that. In this circle is A. This circle is B. All right. Adopting the sign convention towards right as positive. UA is plus 10 since to the right. UB is minus 5 since to the left. VB, he is saying for ball B, it reverses direction. That means ball B has initial velocity just before impact was to the left. That means after impact, it is to the right. So he has given that VB is plus 6. Let's apply principle of conservation of momentum. 20 into mass of ball A is 20 kg, ME, UA is plus 10 plus MB is 30 into UB is minus 5 is equal to ME 20. So 20 VA plus 30 into VB is what? Plus 6. So if you substitute this and solve it, you get VA as minus 6.5. Minus 6.5 means 6.5 meter per second towards left. Now coefficient of restriction. Coefficient of restriction is VB minus VA upon UA minus. You have all the values with us, right? You can find the value. VB is plus 6. VA is minus 6.5. Just now we found it. Minus 6.5 since to the left. UA is plus 10 and UB is minus 5. Substitute all these values. Just use your calculator. You'll get the value of E as 0.833. Is this all understood to everybody? Now we are ready to move to the next sum. Third sum. Prove that for a perfectly elastic impact means E is equal to 1. Two equal masses participating in the collision exchange their velocities. So I have drawn a diagram before impact. Both the bodies have the same mass m and m. This is moving to the left, right with velocity u. This is moving to the left with velocity. E is 1 since perfectly. Now m1 and m2 are m. U1 is plus u and u2 is minus v. Apply principle of conservation of term. M1 is m, u1 is u, plus m2 is m, u2 is minus v, is equal to m v1 plus m v2. v1 and v2 are the velocity of the two bodies just after impact. Okay. Now here, if you m will get cancelled from the equation, so what you get is v1 plus v2 is equal to u minus v. All right. Coefficient of restitution formula. E is equal to v2 minus v1 upon u1 minus v. v2 minus u1. u1 is u, u2 is minus v. Substitute that, you get v2 minus v1 is equal to u plus v. All right. Solving the two equations or adding the two equations, you get 2v2 is equal to 2u. That means v2 is equal to u. And then v1 comes out to be minus v. If you substitute in this equation the value of v2, all right, then you get the v1 as equal to minus v. That means v to the left. So this proves that they exchange their velocities. This proves that, see that, what was the velocity of the ball, first ball before impact towards right? Now velocity of ball 1 before after impact is v to the left. So this was the initial velocity of second ball. Now initial velocity of the first ball was v to the left. All right. Final velocity of the ball 2 is u to the right. So they have exchanged the velocity. This is a general conclusion. Also, we use it sometimes while solving the problems of dynamics, that during impact, if the masses of the two bodies are same and E is 1, the velocities of the two bodies are interchanged during the impact. During the impact, again I repeat that, during impact, if the mass of the two bodies, masses of the two bodies are same and E is 1, I mean it is perfectly elastic impact. So during impact, the velocities of the two bodies are interchanged. All right. Now we are ready for next sum. question number 4, problem number 4. A sphere A weighing 10 Newton moves on x-axis in positive direction, that means towards right, with velocity of 4 meter per second. Another sphere B weighing 8 Newton moving on the same x-axis but in opposite direction. So this is A is of 10 Newton, B is of 8 Newton. A is moving to the right with 4 meter per second, B is moving to the left with 6 meter per second. And impinges on it, E is 0.7. Find the velocity of the two spheres after a collision. Also calculate the loss of kinetic energy. Now, students, you can understand MA is mass, G you can take it as 10. All right, assume the G as 10. So 10 upon 10 is 1 kg. Mass of ball B is 8 kg. 8 upon 10, 0.8 kg. UA is plus 4 since to the right. I've taken sign convention towards right as positive. UB is minus 6 towards since it is towards left. Apply principle of conservation of momentum. MA UA plus MB is equal to MA plus MB. Here it is 1 into UA is plus 4 plus MB is 0.8 into UB is minus 6 is equal to MA1 BA plus MB 0.8. So you get it BA plus 0.8 BB is equal to minus 0.8. E is 0.7 is equal to BB minus BA upon UA minus BB minus BA. UA is plus 4, UB is minus 6. So you get it BB minus BA 7. So you got two equations. BA equation number 1, BA plus 0.8 BB is equal to minus 0.8. BB minus VA 7. Solving 1 and 2, VA is minus 3.56, that is 3.56 meter per second to the left. Minus means it is to the left, because we assume the sign convention towards right as positive for velocity. BB comes out to be positive 3.44, that means 3.44 meter per second towards right. So this way we got the velocity of the two bodies after impact. It is more or less identical what we learned in first problem. Now loss of kinetic energy. Loss of kinetic energy is initial kinetic energy minus final kinetic energy. Initial kinetic energy is half MA UA square. MA is 1, UA is plus 4. All right, plus half MB, MB is 0.8, UB is 6. Minus but does not make any difference. Minus half MA 1. Right, this is BA. BA is 3.56 square plus half into MB 0.8 into 3.44 square. So if you use your calculator, you get it 11.33 joules. You can write it Newton meter also. You can write the unit of kinetic energy as joules or Newton meter. So this way we have found the loss of kinetic energy. Loss of kinetic energy is what? Initial kinetic energy minus final kinetic energy, or kinetic energy before impact minus kinetic energy after impact. All right, students, we have already done 4 problems. In these 4 problems, we saw that we were given with the velocities of the two bodies just before impact, and we were required to find the velocity of the two bodies just after impact. But at times what happens, like the problems of impact are clubbed with the concepts of rectilinear motion. That means you are not given with the velocities of the two bodies just before impact. You are given with the velocity of the two bodies when the motion is happening under gravity and they are certain distance apart. So in that case, first you have to solve it as the problem of rectilinear motion, and then you apply the principles of impact on the sum. So let's take up the sum. Problem number 5. A body of mass 2 kg is projected upwards from the surface of the ground at t is equal to 0. This is body A, which is projected upward with 20 meter per second. 1 second later, body B, also mass 2 kg, is dropped from the height of 20 meter. It is dropped means its initial velocity is 0. Right? Both the bodies are initially 20 meter apart. If they collide elastically, elastically means what? E is 1. Find the velocity of the body A and B just after collision. So first we draw the diagram. We have shown that two bodies are 20 meter apart. A is projected upward with 20 meter per second. B is dropped with the velocity 0. Of course, when this body A goes up, it will lose velocity. Body B, when it is dropped from 0, dropped means with 0 velocity, it will gain the velocity. They will meet somewhere in between. So this is a meeting point of body A and B. So I'm assuming that they are meeting at distance x from the bottom, right? So total distance between the two bodies initially was 20. That means body B will come down by distance of 20 minus x. Time available for body A is suppose t. Time available for body will be B will be t minus 1. All right. Now we'll apply equations of rectilinear motion at constant acceleration due to gravity for body A. I'm applying rectilinear motion. Right here, s is equal to ut plus half at square we have applied. That is x is equal to 20t minus half acceleration is minus half gt square. V is equal to u plus at, Va is equal to 20 minus 9.81 into t. For body B, s is equal to ut plus half at square we have applied. S is plus this time. For body A, as motion was happening upward, we took upward. Body B, we took downward positive. So displacement is 20 minus x. Initial velocity is 0 plus half g into t minus 1. Time available to body B is t minus 1. Identically, we write V is equal to u plus at, Vb is 0 plus 9.81 into t minus 1. Now you can add equation number 1 and 3. If you add equation number 1 and 3, x will go off and time t will be obtained. Right? Adding equation 1 and 3, you get it 20 is equal to 20t plus 4.905 t square plus 1 minus 2t. All right. T square gets cancelled. Further, you simplify, you get the value of t as 1.481 seconds. Now you can substitute the value of t in equation number 2. You'll get V as 5.47 plus. Plus means it is upward. So at the just before impact at this point, velocity of body A is 5.47. If you substitute the value of t in equation number 4, it is velocity of B is 4.72 meter per second and it will be downward. Now, so VA are this velocity of VA and VB are the velocities just before impact. So impact of the two bodies A and B will be happening at this point. At this point, velocity of body A is 5.47 meter per second upward, and velocity of body B is 4.72 meter per second. All right. Now, as VA and VB are the notations we have used for the velocities just before impact, so we'll write VA dash and VB dash be the velocities of the two bodies just after impact. Let's take now impact between two bodies. I take upward positive. Mass of the two bodies are same, so I can write that as m. This is 2 kgs. I don't need to substitute that. M into 5.47 plus m into 4.72 minus. Why minus? Since it is downward. M VA dash plus m VB dash. M gets cancelled. You get VA dash plus VB dash is 0.75. All right. Now we apply coefficient of restitution formula E is equal to 1. So VB dash minus VA dash is equal to UA plus 5.47 minus 4.72. This is UB is minus. So you get second equation, VB dash minus VA dash is 10.19. Solve equation number 5 and 6. You get VA dash as minus 4.72. Minus means it is downward since we took upward positive. VB dash is 5.47 positive, so that means it is upward. You can see the velocity of body A after impact is 4.72 meter per second, and velocity of body B after impact is 5.47 meter per second. All right. Well, we have just now in problem number 3, we had proved that if the masses during impact, if the mass of the two bodies are equal and E is 1, as in this case, the velocity of the two bodies are interchanged. So that same has been proved once again when we applied the impact between A and B over here also. In fact, in this problem, we have not used it directly, this, right? Velocity of the two bodies are interchanged because masses of the two bodies are equal and E is 1. But yes, now in certain problems at a higher level, we use this as a direct, as a conclusion. All right. Okay. Now, in all the 5 problems, what we have done so far, what you saw that masses of the two bodies were comparable. What we observed that the masses of the two bodies were comparable. Comparable masses means what? 2 kg, 4 kg is a comparable mass. 2 kg, 10 kg is comparable. 20 kg, 40 kg comparable. But what is not comparable? Suppose mass of one body is 1 kg and mass of other body is 10,000 kg. So is it comparable? No. So this kind of the impact we come across, like examples are like impact between ball and the floor, impact between ball and the wall, or impact between ball and the ceiling. In these type of the examples, mass of the ball is very small, maybe 1 kg, 2 kg, 4 kg, but mass of the plane, whether floor, wall, or ceiling, is infinitely large in comparison to the mass of the. So when this type the impact happens, when mass of the one body is infinitely large in comparison to other, principle of conservation of momentum is not applied. Principle of conservation of momentum is not applied. I have written this note over here. During impact between ball and the plane, principle of conservation of momentum is not applied since the mass of the floor is infinitely large in comparison to that of. Now we'll use this in this problem. A glass ball is dropped onto a smooth horizontal floor from which it bounces to a height of 9 meters. On the second bounce, it rises to a height of 6 meters. From what height the ball was dropped, and what is the coefficient of restriction between the glass and the floor? So students, I'm assuming that this is before impact. The ball is dropped from the height h. All right. I've just assumed that the ball is dropped from the height h. So we'll apply just to get the velocity just before impact. V square is equal to u square plus 2s, taking downward sign convention as positive. V square u0 plus 2g. So what is velocity of the ball just before impact? Under root 2gh. Velocity of the ball just before impact is, first impact is under root 2gh. Now we'll consider first impact between ball and the floor. All right. I have given index 1 to ball and 2 to floor. So again taking downward positive u1, it is the velocity of the ball just before impact is plus under root 2gh. What is floor? Floor is at rest before and after impact. Floor is at rest, so u2 and v2 are 0. Floor is at rest before and after. Obviously, there will not be any motion of the floor when impact between ball and floor is happening. Right? Now, E is equal to V2 minus V1 upon V1 minus V2. V2 is 0 minus V1. U1 is U1 minus 0. U1 I have not yet substituted. So what you get in V1 is equal to minus E times of U1. Substitute the value of U1 as under root 2gh minus E under root 2gh minus indicative that it is not downward, it is upward. Right? So what was the velocity of the ball just before impact? In this case, was velocity of ball just before impact was under root 2gh down. What is velocity of ball just after impact? E times of under root 2gh upward. What does it indicate? It indicates that with every direct central impact between ball and floor, velocity of the ball changes by E times. That means before the impact, it was under root 2gh down. After impact, it is E times of under root 2gh up. Further, one more example. Suppose velocity of the ball just before impact is 10 meters per second. E is 0.5. So what will the velocity of ball just after impact? 0.5 into 10, that is 5 meters per second. So this is also I have listed. This we should remember that with every direct impact between ball and plane, velocity of ball changes by E times. Direct impact means what? The ball is hitting the plane normal to it. Ball is hitting the plane perpendicular to it. All right. Now, so I'm listing now. Velocity of ball just before first impact under root 2gh down. We proved that velocity of ball just before first impact E times of under root 2h. Now, the ball is after first impact, velocity of the ball is E times of under root 2h. It will go up till it comes to rest. Then it falls down. When it hits the ball again, and when the ball hits the floor again, it will have same velocity with what it had gone up. So velocity of the ball just after first impact is E times of under root 2h. Velocity of the ball just before the next impact, second impact, will be E times of under root 2gh. Right? It is a general conclusion of rectangular motion. Suppose you throw a ball vertically upward with certain velocity, it will go up till velocity becomes 0. Then ball comes in your hand with the same velocity. Right? Now impact has happened. So what is the velocity of ball just after second impact? Again multiply by E square 2gh. That means we understood that if the ball is dropped from the height h, so velocity of ball after first impact will be E times of under root 2gh. And what will be the velocity of the ball after second impact? E square under root 2gh. Now he has given certain conditions in the problem. He says that after first impact, the ball goes up to the height of 9 meters. That means after it goes up to 9 meters, after 9 meters, then velocity is 0. That means it comes to rest after 9 meters. So again, by taking upward positive, we apply motion of the ball, rectangular motion, V square is equal to U square plus V 0. Use E times of under root 2gh square minus acceleration due to gravity will be minus 2g into 9. So solve it, simplified, you get it E square h is equal to 9. Now, after second impact, it goes up to the height of 6 meters. That means after 6 meters, once it has reached the height of 6 meters, it comes to rest. Velocity of the ball just after second impact is E square under root 2gh. Again, we apply equations of rectangular motion. V square is equal to U square plus 2s. V 0, use E square under root 2gh square minus 2g into 6. So E raised to 4 2gh is equal to 2g into 6. 2g gets cancelled. You get e raised to 4h as 6. Dividing equation number 2 by equation number 1 gives e square is equal to 6 by 9, or e is equal to 0.816. Right? Once you get the value of e, you can put the value in equation number 1 or 2. You can get the value of h. So coefficient of restitution in this problem has come out to be 0.816, and the height from where the ball was dropped is 13.5 meter. In this problem, we have drawn two important conclusions we have drawn. One is that when the impact is happening between the ball and plane, we do not apply principle of conservation of momentum at all, because mass of the floor is infinitely large in comparison to the mass of the ball. Also, with every direct central impact between ball and plane, velocity of the ball changes by 3 times. Direct central impact means the ball is hitting the plane at 90 degrees. Let's take a few problems based on this. Problem number 7. A heavy elastic ball drops from the ceiling of the room and after rebounding twice from the floor reaches a height equal to 1/2 of the height of the ceiling. Find the coefficient of restitution. Let h be the ceiling height of the room from where the ball is dropped. Now, if you refer to the previous problem, if the ball is dropped from the height h, right, what is the velocity of the ball after first impact? E times or under root 2j. What is the velocity of the ball after second impact? E square under root 2j. Okay. Now we draw a diagram. You should derive. You have to solve it completely as in the previous one. Now we draw the diagram. After second impact, velocity of ball E square under root 2j. It goes up to the height of h by 2. Then its velocity becomes 0. Apply equation v square is equal to u square plus 2s, upward positive, v is 0, u is e square under root 2gh square whole square minus 2g, h is s is h by 2. All right. Now open it out, open this bracket. So e raised to 4 into 2gh is equal to gh. 2 gets cancelled. You take minus. You are taking on other side. So now gg gets cancelled. You get e raised to 4 as 0.5. Taking square root 2 times in your calculator, you'll get e as 0.84. So in this problem, I did not show the steps again. We use the conclusion or results of the previous one, as it was possible to be used. Next, problem number 8. A boy throws a ball vertically downwards from the height of 1.5 meter. The boy throws the ball downward from the height of 1.5 meter. He wants the ball to rebound from the floor and just touch the ceiling of the room, which is at a height of 4 meter from the ground. If the coefficient of restitution is 0.8, find the initial velocity with which the ball should be thrown. Now the ball is thrown with velocity u. It is before impact from the height of 1.5. So I can get the velocity of ball just before impact. Taking downward positive, v square is equal to u square plus 2s. S is 1.5. Okay. U is unknown. U square plus 2j, 2 into 9.881 into 1.5. P is equal to square root of u square plus 29.4. Now I can use the conclusion. Ball is hitting the plane at 90 degrees. So velocity of the ball changes by e times. E is 0.8. So velocity of ball just after first impact is 0.8 times of this. Before impact, it was downward. After impact, it is upward. Now we'll draw another diagram showing the velocity of the ball after impact. Velocity of the ball after impact is 0.8 square root of u square plus 29.4. It goes up to the height of 4 meter and just touches the ceiling, which is that there at 4 meter. That means it comes to rest. Just touching the ceiling means what? It comes to rest. Now again apply, taking upward positive, v square is equal to u square plus 2s, v is 0, u is 0.8 square root of u square plus 29.43 whole square u square minus acceleration is negative 2 into g into h. H is 4. Solve it, simplified, you get the u as 9.654. What do you get it? U as 9.654. Now in this problem, the ball was thrown with velocity u from the height of 1.5 meter. We got the velocity of the ball just before impact. Then we got velocity of the ball just after impact. It is multiplied by e times. That is e is 0.8. Then the ball just touches the ceiling, which is at the height of 4 meter. That means the ball comes to rest after traveling upward by 4 meter. Again, we apply v square is equal to u square plus 2s, v 0, u is velocity of the ball after impact, and acceleration due to gravity is minus, and h is s is 4 meter. So we solve it. So this is the velocity of the ball needed if you throw it from the height of 1.5 meters, so that after impact it just touches the ceiling of height 4 meters. Okay. Let's take problem number 9. If the ball is thrown vertically down with a velocity of 10 meter per second from the height of 3 meter, find the maximum height it can reach after hitting the floor if the coefficient restriction is 0.7. All these problems are quite important, asked for 4 marks or 6 marks in examination. All right, same kind of the equations we have been applying in the last two sums. Now see that in this. Now the ball is thrown with the velocity of 10 meter per second from the height of 3 meters. It is status before impact. V is the velocity just before impact. Apply V square is equal to U square plus we are taking downward positive. V square is equal to U is 10 square. Acceleration due to gravity is positive, plus 2 into 9.81. So what is value of V? 12.6 meter per second before impact. What will be the velocity of the ball just after impact? Need to simply multiply by E, that is 0.7. Hence the velocity of ball just after impact is 0.7 into 12.6, that is 8.8. All right. After impact velocity, the ball is 8.82. Up to what height it will go? Maximum height will be attained by the ball when velocity is 0. Apply V square is equal to U square plus 2s by taking upward positive. V is 0. Use 8.82. Acceleration due to gravity is minus. So minus 2 H. H is required. So you get H 3.965 meters. So that means after impact, it is 0.7. This ball will go up to the height of 3.965 meter. One more problem of same type, but this time we'll calculate the total distance. We are considering the impact between ball and the floor, but this time we'll calculate the total distance covered by the ball during the entire impact process. During the entire impact process, number of impacts will be happening. So ball will go down, will go up, will go down, will go up. So we'll calculate the total distance, what it covers during certain impact of this time. Now let's understand the sum. A ball falls from the height of 1 meter, hits the ground and rebounds it with the half of its velocity just before impact. That means E is 0.5. That means velocity of the ball is changing to half. That is possible only when E is 0.5. Then after rising, it falls, again hits the ground, again rebounds with the half of its velocity. That means after second impact also again E is same, that is 0.5 and so on. Determine the total distance traveled by the ball till it comes to rest on the ground. Now students, H is 1 meter, E is 0.5, that's what we understood. We are just considering this height as H in general form. Later on, we'll substitute the value of H. All right, it will be easy for one. What will be the velocity of the ball just before impact? Applied equations of rectilinear motion, taking downward positive because motion is happening downward. V square is equal to U square plus 2s. U 0. Acceleration due to gravity is plus V into H. So V is velocity of the ball just before impact is under root H. What is velocity of the ball just before under first impact is under root 2j downward. Velocity of the ball just after first impact, E times of under root 2j. Right? Now, we'll calculate now the distance. We have drawn a diagram after first impact. Velocity of the ball is E times of under root 2j. How long it will go till velocity becomes 0 and it covers the distance H1 we are assuming. So velocity of the ball after first impact, we'll calculate this. V square is equal to U square plus 2s to get the distance. V0 is E times of under root 2gh square minus 2gh1. H1 comes out to E square h. Now, second impact. Velocity of the ball just before second impact is E times of under root 2gh. We have already understood in the previous example also. What will be velocity of ball just after second impact? E square under root 2gh. Now, here, look at this diagram. What is velocity of ball just after a second impact? E square under 2gh. I assume that it goes up to the height h2. H2 will be definitely a little lesser than H1. Its velocity is 0. Apply equation rectilinear motion taking upward positive. E square is equal to U square plus V0. U is E square under root 2gh whole square minus 2g H2. H2 is E raised to 4h. You saw that after first impact, see, it was dropped from the height h. After first impact, it went up to the height of E square h. After second impact, it went up to the height of E 4h. So after third impact, it will go up to the height of e raised to 6h. After fourth impact, it will go up to the height of e raised to 8h. All right. So what will be the total distance? Total distance is h plus 2h1. Why 2h1? After first impact, it goes up to the height h1 and falls down by height h1. So 2h1. Similarly, after secondary impact, it goes up to the height h2, falls by h2. So h plus 2h1 plus 2h2 plus 2h3 plus 2h4 and so on. Now, how it comes? H plus 2 square h plus 2 e raised to 4 h plus 2 e raised to 6h plus 2 e raised to 8h. Now, total distance h plus second term onwards, we can take 2e square h common, 1 plus e square plus e raised to 4 plus e raised to. So it reduces to a geometric progression. What it reduces to a GP. For GP of this kind, what is sum? A upon 1 minus r. A is first term and r is common ratio. What is first term here? 1. What is common ratio? The common ratio e square. So I'll substitute this. H plus 2 square h. Right? What is summation of the series? First term 1 upon 1 minus e square. All right. Simplify it, solve it, simplify it. You get h1 minus e square upon here it is plus sign. By mistake, it has come minus 1 plus e square upon 1 minus e square. All right, when you simplify, right, and then it will come out to be in this manner. H into 1 plus e square. In the numerator, it is plus sign upon 1 minus e square. Right, it is in general form. Now you can substitute the value of h and e. H is 1, h is 1 meter, and e is 0.5. Substituted. So 1 plus 0.5 square, 1 minus 0.5 square, it comes 1.667. So total distance traveled by this ball during the entire impact process is 1.667. So this way we can calculate the total distance traveled by the ball during the entire impact process, right? So impact will keep on happening one after the other. All right, with every impact velocity, the ball will go on reducing. Also, the distance traveled in the next impact will be lesser than previous impact. Okay. Students, we have covered 10 problems. We have covered 10 problems. All these problems were on direct central impact. What is direct central impact means? What? The velocity of the two bodies were collinear with line of impact, and CG of the two bodies were lying on line of impact. Now we are moving to the problems of oblique central impact. Oblique central impact means CG of the two bodies will lie on the line of impact, but initial velocities, I mean the velocities of the two bodies just before impact will not be collinear with line of impact. So they will be at some angle. All right. So in that case, we have to resolve the velocity components along the tangent and along the normal. Tangent means what? It's a common tangent, common surface of contact. That is, we call it common tangent. And normal means what? Along the line of impact. But sign convention has to be adopted. Right? When we resolve the velocities along the tangent, along the normal, tangent means common surface of contact. Normal means line of impact. All right. So during impact, tangential components remain same. Tangential components is just rubbing, and we are considering the balls as frictionless. So there is no change in the velocity components along the tangent. But velocity components along the normal will change as per the concepts of direct center. Normal components will change during oblique impact as per the principles or as per the concepts of direct central. Now let's start with the problem. This is what I have listed. This is to be remembered. What you need to remember, again I repeat that, you need to remember that tangential components remain same and normal components change as per the rules of direct central impact. Now question number 11. The magnitude and direction of the velocity of the two identical balls before central oblique impact are as shown. The figure E is 0.9. Determine the magnitude and direction of the velocity of each ball after impact. Find the loss of kinetic energy during impact. This is ball A, this is ball B. Initial velocity of the ball A is 9 meters per second at 30 degrees. 12 meters per second is the velocity of ball B at 60. Now we need to draw this diagram again. Over here you have drawn. We have to identify tangent. I hope you understand common surface of contact is vertical in this case. This is tangent direction and this is line of impact. Yes. I have written T plus here. T plus is indicative what tangential component will be taken upward positive. Here I have written n plus. This indicates that normal components will be positive towards that. Now we resolve it. This velocity. This will be 9 sine 30 will be upward, tangential component positive, and 9 cos 30 will be normal component, that will also be positive. So UAT is plus 9 sine 30, UA normal is 9 cos 30. Now come to ball B. Ball B is 12 meter per second. So tangential component is positive, 12 sine 60, UBT, 12 sine 60. What is normal component? 12 cos 60. It is to the left. Normal component of the ball B is to the left. That means it is negative. So UBN is minus 12 cos 60 minus 6 meter per second. So students, first we list all this tangential and normal components after adopting sign convention along the tangent and normal. Here we took sign convention, tangential upward and normal towards right. Now motion along tangent. Motion along tangent, velocity of the ball along the tangent will remain same before and after impact. So VAT and UAT are same, that is 4.5 meter per second. Similarly, VBT and UBT are same, that is plus 10.392 meter per second. Now, as we have written a note, tangential components of the velocity during oblique impact remain same, already we have discussed. Now we take motion along normal. When I'm taking the this part, motion along normal, you have to consider only normal components, and you have to solve the problem absolutely as the problem of direct central impact, but with only normal components. Now see that here, motion along normal. So what I'll write, masses are same, masses are same. So MUN plus MUBN is equal to MBN plus MUBN. Masses are same, so this is UN plus 7.794. UBN is minus 6, I substituted, is equal to VAN plus VBN. So VAN plus VBN comes out to 1.794. Coefficient of restitution formula. E is equal to VBN minus VN upon UN minus UBN. EB aa gaya hai, it is VB actually. I hope you understand. 0.9, E is 0.9. VBN minus VN is equal to UN plus 7.794. UBN is minus 6 substituted. Cross multiply, you get it. VBN minus VN is this. Solving 1 and 2, you get VAN as minus 5.311 and VBN is plus 7.104. So you have got now normal components after impact. You got tangential component after impact, which will remain same. Tangential component before and after impact are same. Normal components we have got after impact. Now you have to club the tangential normal components after impact. Ball A. Normal component is minus 5.31. That means it is to the left as per the sign convention. Tangential component of ball A is 4.5 meter per second. Positive means upward. So you have drawn the diagram. You have shown VAT, VN, and this will be VA. So what is VA? 4.5 square plus 5.311 square, right? It comes out to be 6.961. All right. And tan theta is equal to 4.5 upon 5.3. It comes out to 40%. Similarly, for ball B, tangential component is positive, that is 10.392. Normal component is positive 7.104. That means it is to the right. So if tangential, one component tangential is upward, normal is towards right. So resultant velocity is this way, making angle alpha. BB is equal to 10.392 square plus 7.104 square root. You get 12.5. Then angle what BB is making with the horizontal, tan alpha is 10.392 upon 7.104. Alpha is 55.64. So this way we have got the resultant velocity of the two balls or two bodies after impact, after oblique impact. Now he is also asking loss of kinetic energy. What is T1? Kinetic energy before impact, total kinetic, half into m into UA square, right? Plus half into m into UB square. You get it 112.5. What is total kinetic energy after impact? Half into m into VA. VA is what? 6.961 plus half into m into 12.588 square. You get it 103.46. What is loss of kinetic energy? T1 minus T2. It comes 9.04 m. Why it comes in terms of m? The value m was not given. So T1 and T2 will come in terms of m. Even loss of kinetic energy will also come in terms of m. So loss of kinetic energy is 9.04 m joules. Let's take a few more sums on oblique center impact. Concept remains same. All right. Next problem. Two balls of masses 0.12 kg collide when they are moving with velocities 2 meter per second and 6 meter per second perpendicular to each other as shown in figure. If the coefficient distribution between A and B is 0.8, determine the velocity of A and B after impact. Now you can see that if this impact is happening in this manner, common surface of contact or common tangent will be horizontal and line down perpendicular to that line of impact will be vertical. Right? Like in the previous problem, common tangent was vertical and line of impact was horizontal. Here, line of impact will be vertical, common tangent will be horizontal. Also, here's given the velocities in such a way that you don't need to do much work because one component will become zero, other component will only be right. Now let's mark the normal and tangent. I mark tangent T plus. This is I mark N plus. This is UA. This is all right. This is line of impact. This is now for ball A, tangential component is positive since to the right plus 2 meters. Its normal component is 0. Right. Come to ball B, its tangential component is 0. Normal component is plus 6 since it is up. All right. Motion along tangent. Its tangential component before and after impact remains same. BAT and UAT are same plus 2. BBT and UBT are 0. Now motion along the plot. MUN plus MUBN is equal to MBN plus MN. Masses get cancelled. UN is 0. UBN is plus 6. BBN and BN and BB. So you get this equation BN plus BBN is 6. Coefficient of restriction formula is equal to BBN minus BN upon UN minus UBN. T is 0.8 given. BBN minus BN is equal divided by UN is 0 minus UBN is plus 6. So you get another equation BBN minus BN is minus 4.8. Now students, we can solve these two equations. This is your equation number 1. This is your equation number 2. Solving these two equations, all right, you get VAN is plus 5.4 meter per second and VBN is plus 0.6. Now we draw a diagram showing the velocities to correct directions for ball A. Tangential velocity component was plus 2, that means to the right, and normal component plus 5.4, that means it is up. Find resultant velocity. VA is equal to 2 square plus 5.4 square, 5.76. Tan theta is what? 5.4 upon 2. That is theta value stuff. For ball B, tangential component was 0. So I've shown 0. Normal component is plus 0.6. That means upward. So this normal component itself becomes the resultant velocity, and that is vertical. So concept remains same as in the previous one, but here the working becomes relatively easier because not much resolution is involved, and he did not ask loss of kinetic energy and all that what was asked in the class. Let's take one more problem on this type. That is problem number 13 of my today's lecture. This is my last problem of this lecture. Just before they collide, two discs on a horizontal surface have the velocities as shown in figure. Knowing that 90-Newton disc rebounds to the left with the velocity, that means velocity of disc A after impact is given to you 1.8 meter per second to the left. Determine the rebound velocity of 135 Newton disc B. Also find. Diagram is given to you. Velocity of disc A before impact is 3.6 meter per second to the right. Velocity of disc B is 3 meter per second at 35. Right? VA is given 1.8 meter per second to the left. Coefficient distribution is required. Assume G as 10 because we have to convert the weight of the disc into masses. We have drawn the given diagram. We have shown the velocities again. This is UA. This is UA. This is common tangent. I write T plus. That means tangential components are taken upward. This is normal components are taken towards right as positive. Now mass of disc A is 90. Is its weight 90 upon 10. 90. Mass of disc B is 135.10. Now, tangential component of disc A is 0. Since it is a normal component of the disc A is plus 3.6. Since to the right. For ball B, tangential component will be 3 sine 35 downward. So that is minus. 3 cos 35 will be to the left normal component. That will also minus since normal is to the right. Motion along tangent. Tangential component remains same before and after impact. So VAT is UAT, VBT is VBT. That is minus 1.7. Now motion along the normal, we have to solve it as the problem of direct central impact, but with normal component. This is MA UM, MB UBM, MA VN, MB VBN. So values have been substituted. So it comes out to 9 VN plus 13.5 VBN is equal to minus 0.77. It is one equation. E is equal to VBN minus VN upon UAN minus UBN. UAN and UBN values are substituted. UAN is plus 3.6. UBN is minus 2.457. Solve it, you get another equation. Now you've got two equations in terms of VA and VB. Solving these two equations, you get the other values. But in this problem, he has already given to you VA value. VA is given 1.8 meter per second to the left. If it is to the left, that means its tangential component, already we have understood it 0. It is nothing but it is normal component. Since tangential component is already understood to be 0, its normal component is minus 1.8. So we substitute in these two equations VAN as minus 1.8. In equation number 1, if I substitute VAN as minus 1.8, you will get value of VBN. So VBN comes out to be plus 1.143. That means it is to the right. Now when we go to the other equation, from equation number 2, right, you substitute the value of VN, you substitute the value of VBN, you get the value of VN. So VBN is 1.143 plus VN is minus 1.8 and right hand side is 6.06. So you get E as 0.486. Now for this A, the resultant velocity was already given 1.8 meter per second. For this B, we need to find the resultant velocity. You need to draw a diagram with the correct directions. Its tangential component of ball B was minus 1.721, so that is downward, so 1.7. Normal component after impact came out to be 1.143 positive, that means to the right. So now resultant velocity is like this, making angle theta. So VB is what? 1.143 square plus 1.721 square. You get resultant velocity of theta is tan inverse of 1.721 upon 1.143. That comes out to be 56.4. So students, we have covered 10 problems on direct central impact in this lecture. We covered 3 problems on oblique central impact. This is my part 1 or first lecture on this topic of impact and impulse and momentum. That is comes under kinetics of particle part. All right, I'll be taking one more lecture on this topic, and with that Mumbai University syllabus will be complete. After that we will have lectures on the autonomous institutions syllabus. Mumbai University syllabus, one more lecture of mine is required. We are on the last topic of as per Mumbai University syllabus. All right, students, you are again requested to share the QR code of my YouTube channel so that more and more students are benefited. There is no compulsion to buy the book. There is no compulsion. One can understand my lecture even without referring to the book. But if you refer to the book of mine, that is engineering mechanics book of mine, you will definitely have the better insight to the subject. There are many more solved problems are given. There are multiple choice question MCQs are also given, right? Some unsolved problems are also given. One can buy the book from Amazon. Amazon link is given in the description of every video. All right, our book is also available on all the bookstores in the city. All right, students, thank you very much.